Hey everyone, and welcome back to the channel Notes for You. Ever look at electrical system, power grids, motor, transformers, and felt like the numbers were all over the place? Different voltages, huge current, it can get confusing last. Well, today we are going to unlock a secret tool that electrical engineers use to make things seem much simpler. It's called a per unit system. For now, let's forget about electricity for a second and think about how strong people are. So imagine you want to compare the strength of a child, a regular adult, and a weightlifter. If I just tell you how much they can lift in kilograms, the number will be different. Maybe 20, 80 kg and 200 kilogram. It's hard to quickly see how much stronger one is compared to others in a simple way. But what if we create a base strength? Let's say the average adult can lift 80 kg. Now we can compare everyone's strength relative to this base. So now the child who can lift 20 kg would have a per unit strength of 20 divided by 80, which is 0.25. So they are 0.25 times as strong as our base. So what was our base? 80 kg. The regular adult who can lift 80 kg would have a per unit strength of 80 divided by 80, which is 1. So they are exactly as strong as our base, 1 per unit. The weightlifter who can lift 200 kg would have a per unit strength of 200 divided by 80, which is 2.5. So they are 2.5 times as strong as our base. So if we compare these three, the child is 0.25 times strong as our base. Regular adult would be 1 per unit, and weightlifter is 2.5 times as strong as our base. So now you can see how this per unit number 0.25, 1, 2.5 give you a much quicker and clear idea of the relative strength compared to each other, even though the actual lifting amounts were very different. So you can now easily understand that how per unit system work. Now you see how this per unit number 0.25, 1 and 2.5 give you a much quicker and clear idea of the relative strength compared to each other, even though the actual lifting amount was very different. Now connecting this back to the electricity, the per unit system in electricity does the same thing with things like voltage. Now think of voltage that make electricity flow. In a big electric system, the voltage can be different in different parts, like transformer, like line voltage. So in electrical system, this voltage can be different in different parts. Now instead of always dealing with those different actual voltage, like a small voltage, big voltage, we choose a base voltage for each part of the system. Okay, so we choose a base voltage for each part of the system. Now we can express the actual voltage in that part as a per unit voltage, how strong it is relative to our chosen base voltage. So as we know, we pick some base value for power and voltage, then we'll convert all the actual value like actual voltage, current or impedance into per unit values by dividing them by their corresponding base value. Okay, so what's the formula? The formula is per unit value is equal to actual value by base value. Means instead of saying the voltage like 13,000 volt or 11 kV, it might become 1 per unit. A current of 500 amperes might become 0.95 per unit. So this per unit system will reduce the complication of the number. So what is the reason behind and what is the benefit of this per unit system? The first is it simplifies the calculation, means it get rid of this large number, making calculation much easier. Second, easier comparison, means we can easily compare the relative size of different components, means a per unit impedance of 0.1 is generally considered small, whether it's for a small or a large transformer. Next is the manufacturer data, means it provides the impedance of their equipment in per unit value, so we can easily understand the system, which can be help to easily use the data. We can easily read the data, and there will be a few errors as compared to the number of complications number. Okay, so these are the benefits of per unit system.